we are going to finish the solving unit or the section today. Now, last class, when we started to solve quadratics, we started with isolating x. And we chose isolating x because there was just one x. Okay? Now, what do I need to remember about isolating? I do PEMDAS backwards, right? The general idea of undoing operations. The other thing that I need to remember is that when I square root, I get that absolute value, which gets me the plus and the minus section. Okay? That is the general idea of how to isolate. Now, what's not on this list is being careful with my arithmetic and my radicals. Okay? That's something that you can do problems for practice. But the general concept is what you need to be familiar with. Next, we learned about factoring. Why did I choose factoring? Because there was more than one x. Means isolating was not an option. Okay? Okay, so when I was factoring, I had two things. First, I set each factor to 0, so I could use the zero product property. And then I took each factor to 0 to get my solutions. Today, we're going to do the complete the square method. And I haven't written up the rest of the pieces here yet because I want to learn them before I summarize them. But complete the square is, notice that I can't isolate because I have more than one x. And I can't factor. Otherwise, I would be using the number 2 technique. Okay? So we are going to look at solving equations using this method called complete the square. Yes?
What makes it not factorable?
The multiply add numbers don't work. So there's no set of 2 numbers that will work. Yes, question.
Also on the how to factor quadratics, what is that orange? Like what part is it? It's on the how to factor quadratics page.
It is a pattern because it's a perfect square trinomial, which is what we're going to start talking about today. But it's also just a trinomial, so multiply add numbers also work. Yes.
Is it not factorable after you multiply a times c?
Yes.
Okay.
Yes. Okay. All right. So we're here. We're going to do 2 things today. One of them is we're going to learn what complete the square means. And then the second thing is we're actually going to use it to do the solving. Okay? So here we go. Zoom back out. 3.4. Complete the square. So the first thing we're going to do is we're just going to talk about perfect squares, okay? And we're actually going to talk about perfect square trinomials. Trinomials. Okay. And so I'm going to write down that formula again. Okay, so that comes from the factoring lesson. And notice that I just included the plus or minus in the same expression here. This is a perfect square trinomial because it factors to the same factor twice. Okay? That's why it's a perfect square trinomial. Okay, so here's the question. Find the missing term to make a perfect square trinomial. So I'm going to put in a couple blanks here, and we're going to try to fill in the blanks. Examples. Okay, so I left off the third term. Now I know that this is supposed to be a perfect square trinomial. So my goal is to write it like this. That's what it says. Find the missing term to make this trinomial a perfect square. Okay. Well, I could do a little guessing and checking here, but I'm just going to write my two factors underneath of this, and I'm just going to try. It has to be a perfect square. So I know that 4 is 2 times 2. Has to be the same thing. So I'm just going to fill in, right? It's still a little bit of guess and check or process of elimination. I know it has to be 2x and 2x. Okay, so that's the first. Okay, I now have outer and inner. Now, outer and inner are the same. They're the same. They're just doubled. Okay, so yes, for perfect square trinomials, they are always the same. Because notice here my formula is 2 times AB, means that the term is doubled. Okay, so that tells me that my middle term is split to 2x plus 2x. That's my outer and my inner. So what am I going to fill in to these blanks? Yes, Sasha. A 1. Okay. Now, how are we going to fill that blank? Eve?
So you take this 4, wait, in the last page.
Yeah, this one right here.
So you take this 4 and then you divide it by 2 and then you multiply, well you get 2 and then you multiply 2 by 2 and get 4.
Almost. I know exactly what you're saying. And I'm going to have you repeat that in like 5 minutes. Yes?
I got a question. Will it always be the rule where like you have when it equals the same thing? Do they have to add up to equal the 4x? Like if it was 8, would it be 4x plus 4x? So your numbers would be plus 2 plus 2.
Mm-hmm.
So is that kind of always the rule where it would be like
Mm-hmm. It is. All right, so 1 times 1. So the number is a 1, right? It's the last. Okay, so how does it factor? 2x plus 1 squared. Okay, 9x squared. Minus 24x plus. Okay, we want to fill in the blank so that it will factor to a perfect square trinomial. That means the same factor twice. So I'm just going to start by putting down my factors. And, right, same, it's got to be the same thing. So I'm going to choose 3 times 3. Yes?
If it were the outer term that you're trying, the one with the blank, and you had like one of the others, it would also be multiplying, right? Because you know A and C are always multiplying and B is always adding.
Yes. Okay. Now, look at your middle term. you have to half this middle term because the outer and the inner are exactly the same. They have to combine to minus 24, but they have to be the same. That's why I was splitting this, minus 12x and minus 12x. They have to be the same. Okay, what goes here in that spot? Yes?
-4.
Minus 4. 3x times what gives me minus 12x? Okay, so 3x minus 4. Notice, okay, 4 times 4 is positive 16. So that's the number that's missing to make this a perfect square trinomial. Yes, Duncan.
So, whatever the outside one, that's what you're multiplying.
Yes. It's still a trinomial, right? Which means the foiling still works. Okay, so let's try one more. I'm going to let you try it. Yes? What's negative times negative? Positive. No, good question. So that last term, if I check my little formula, that last term is always positive. It's only this middle one that could be either. Okay. Here we go. 16x squared hold on. My arithmetic is lacking. Okay, plus 56x plus what? Okay, perfect square trinomial. This one has to be 4 times 4. Has to be. Right? We need the same number here. I just don't know what it is yet. Okay, 4x. So I'm setting up my FOIL, and I'm trying to figure out what the outer and the inner have to combine to. So divide this by 2. That's 28x and 28x. Yes?
So it would be plus 7.
Yes, it would be plus 7. Because 4 times 7 is what gets me 28. Okay, so I would have a 49 here and a 4x plus 7 here. Notice that we had to create the number to get there. All right. I get it. You're like, oh, that's a lot of thinking. Could I please try to simplify this? Yes. 4, 9, and 16 are all perfect squares. But what's the smallest perfect square? 1. Yeah.
I have a question on number 2. Is there a reason why you didn't highlight the negative on the first floor?
Oh, no. No.
I was wondering because I didn't know if that was like.
No. Just missed it. Okay. So notice that when the square is not a 1, it gets a little bit tricky because you've got all this combining of inner and outers to work with. So what we're going to do is we're going to simplify it. And now the next examples are only going to have a 1 in front. Okay? And we're going to see how much easier that can be for us. Okay, x squared plus 6x plus what? Okay. And I'm going to put this in parentheses. Okay. I'm also going to draw a Punnett square. Yeah, biology. Okay. And I'm still trying to make this a perfect square trinomial. Okay. Well, x times x. Got it. Good. Now it's got to be the same number. Okay, so the way my Punnett square works, I need to split my middle term evenly. Plus 3x and plus 3x. Why? Because it's a perfect square trinomial. The outer and the inner are exactly the same thing. That's why I split it evenly. Now, a Punnett square is really just another way to organize your grouping. So what's the greatest common factor here? X. Okay? X. All right. X times what gives you 3x? 3. X times what gives you 3x? Those are the factors. X plus 3 times x plus 3. Okay, what goes in the missing box? Lori? A 9, because it's 3 times 3. Do you notice how I am literally geometrically completing the square by adding a 9? That's why it's called complete the square, because you are literally filling in the box with the number that completes the square with a positive 9. How did I get it? 3 times 3. I see your question. 1 second. Okay, so I'm going to put a 9 here. And you can do it this box way. You can do it this way. Half it. So a 3 and 3. Right? Half it, because the inner and outer have to be the same. So it's x plus 3 squared. Okay, question up front.
So, obviously I know how to do like the 3x, but how do you know to place the x squared in the top left and the 3x in the bottom left and top right?
Okay, so let me write it out like this. It's literally, instead of going all the way across like this, I just put the first 2 terms in the first row and the second 2 terms in the second row.
Oh, so you go left.
Yeah, so you
down.
just start in the top left.
So basically, if it were x squared plus 3x plus 5x plus 9, it would be x squared, 3x, 5x.
Yes.
Thank you.
Okay, here we go. Let's do another one. X squared minus 8x plus what will make this a perfect square trinomial? All right, so I'm just writing out my factors here to help me think about it. All right. I can write out my box, right? I like multiple visual cues to help me. Write out my box. Okay. So because it's a perfect square trinomial, I have to split my term evenly. So that's minus 4x and minus 4x. And I consider my Punnett square, so x times x. The missing blank positive 16. Oh, that works. My outer and my inner, the same number. Yes.
How do you know to put the -4 above?
When there's a negative on the top row or the left column in front, you always take the negative with it. Now also notice here that minus 8x has to combine, so you're going to get a negative 4x from the outer and a minus 4x from the inner. So you've got to have a negative there.
But how do you know like to put the 4 on you don't know the box?
Oh, okay, good question. Let me show you. There is only one choice to go there, so let me just draw my box over again. Okay. So I know that I have this because those two boxes have to be exactly the same. Now, the only way to get x squared is x times x. Okay? So what I'm looking at is how do I multiply those two things together to get minus 4x? So x times what gives me minus 4x? That's how you know. Okay, so here we go. Can you fill out this one? Yes.
I'm a little confused on why it's like the negative 4 with the outside. Is it because like that's what leads to?
Get to minus 8x? Yes.
Oh, never mind. I got it.
Yeah, okay. That's fine. It's good because the plus and minus is really the only thing that's different between the two problems.
I just forgot the rule.
Yeah. Okay. Write this as a perfect square trinomial. This one?
Oh, it's part of the wrong column, sorry.
Yeah. Sorry, there you go. There you go.
I was wondering why this was negative.
Yeah. Okay. Who wants to share? All right, Rand. Yeah, just tell me. Yes, so you got a 36. Okay, hold on. How did you get the 36? How'd you get negative 6 and 6? Yeah, we split my middle term into 2 equal parts. Okay.
Things that multiply, or like the inside and outside thing, so we negative 6 and negative 6.
Yep. So it's 6 times 6. Yay! Okay. Good. All right. So you've got the process. Notice, let's zoom out, let's take a look. Okay, so Eve, you said something about halving and squaring. Do you want to say that again?
Yeah, so basically what I was looking for is like if you were to take a -12 and divide that by 2, you would get negative 6. And then you take that and you do -6 times -6, which then you would get 36. That's just like an easier way instead of doing the whole box.
Okay, so Eve simplified it because if I want to split this evenly, I divide it by 2. Okay? Divide it by 2. Then I do that number multiplied by itself, which is squared. And that's the number that you add. Half it, square it. Half it, square it. Why do I half it? Because I have to split it evenly. Why do I square it? Because that's how I get the last term. Half it, square it. Okay, so notice, right? The 6 is what goes here. The 36 is what goes there. All right, I'm going to show you a little bit of arithmetic, and then I'm going to let you work for a little while. Okay. All right, so 7. Just 2. X squared minus 3x plus what? Ooh, fractions. You can do it. Right, I still need to make this a perfect square trinomial. X times x. All right, you gotta half it. Just leave it as a fraction, guys. Don't say 1.5. Leave it as a fraction. Okay, so I'm gonna half it. That is, I'm gonna do it over here. Negative 3/2. Half it. Square it. Okay, so I halved it. So that means I'm gonna get this. Half it. Square it. Okay, so when you square something, it is just multiplied by itself. So that's straight across, and that's 9/4. So 9/4 is the number that we're missing. But it factors with the minus 3/2. Fraction. Okay. It's not the concept. It's the arithmetic. Anyone know how to divide a fraction by 2? Yes. Multiply it by 1/2. Okay, so I'm still going to write my parentheses here because it really just helps me think about it. So I do need to split this thing into 2 even parts. Okay, so I'm going to write the word half. Because in order to half this, I'm just going to I want half of the middle term. So multiply it by 1/2. So that's negative 7/6. And then I'm going to square it. That's the number you're missing. Okay. 49/36, but be careful because that half number, that's the number that I'm using to make my factor. Solving with complete the square. Okay. Now, we've already sort of talked about why we're going to complete the square. It's because I can't isolate and I can't factor. So we're going to complete the square. Notice by completing the square, we ended up with a single x. Okay, a single x, look at our chart, takes us all the way back up to now I can isolate. Right? There's really only 2 ways to solve. Isolate or factor. If factoring doesn't work, you turn it into a perfect square so that you can isolate. Yes? Okay, when we completed the square, notice how we went from a trinomial to the parentheses squared, and there was only 1 x in that statement. I'll highlight it when we do it, okay? All right, here we go. So, when you can't factor, first thing, if you can't factor, then this is what you're left with, okay? Make a value equal to 1 because it works best if there is a 1 in front. Half it, square it. Half it, square it. It works best if there is a 1 in front. Okay? X squared plus bx plus a number. It works best if there is a 1 in front, just like all those examples we just did. So how do I fill in this missing blank? And how do I factor it? Okay. I'll use green because it's different. Okay, we just practiced the complete the square step. Half it, square it. Half the middle number. That's what I want. Half of the middle number. B over 2, half it, square it. So this is the B squared over 4, or whatever it turns out to be, right? Half it, square it. Okay, what number is this? This is the halved number. Okay, so you're like, all right, I kind of get it. This is like the formula part. Notice here that you've got 2 x's. Notice here after you factor it, you only have 1. That's why isolating works. Okay? That's why isolating works. Okay. Solve by complete the square. That's what the C is. Complete the square. I'm going to number my steps, okay? This is just me remembering and formulaing the complete the square step. Why am I going to use it? Because it goes from multiple x's to 1x. Okay, first thing you have to do is get it set up. You have to set it up. How do you set this up? You make it look like this. A squared plus bx. Notice how I put the x's on one side and I moved the number to the other. Okay. What's the next thing? Oh, because I'm going to put a blank in here. 2. Actually complete the square. Like, actually fill in the blanks. Fill in the blanks by completing the square. Why might I do this on both sides of the equation? Because it's a balance. If you're going to add 4 to one side, you need to add 4 to the other side. It's an equals. You got to do the same thing on both sides. Okay? And factor equals some number. That's not the important part. Okay? Set it up. Complete the square. Guess what? Now you isolate. Right? Now you isolate. Go back to what we've already learned. Now you isolate. Yes?
Wait, but if you have, like, if you move the number to the other side, wouldn't it be negative?
Yes. Let's just not worry about the actual signs of the numbers. Worry about more of the location right now.
So that b squared over 4 would theoretically be, where did this come from?
There you go. Is that better?
Yes.
Okay.
But wait, where did this come from?
What? Oh, let's just say it was like, let's do the example, okay, so that I can show you with real numbers. All right, here we go. Let's start with x squared minus 12x plus 7 equals 0. You're like, yeah, trinomial, let's factor. Mer. It doesn't factor. Yeah.
This is like nothing, like the 2 numbers don't multiply.
Okay, so can I multiply to 7 and add to 12? No. No. So if I can't factor it, then the only thing left to do is to complete the square. So I'm going to set it up, which means I'm going to leave the x's on one side, and I'm going to make my blank for making the perfect square trinomial. Okay, that's the spot you have to fill in. Okay, what goes in the blank. Okay, that's the setup stage. Set it up. Fill in the blank. Right? We just practiced filling in the blank. You should feel pretty good about the blank. Who wants to tell me what to put in the blank? Sure, go for it, Eve. 36. Fantastic. 36. You want to do a little work over here? Half it. Half it. Square it. Okay, half it, square it. Half and square. Okay, set it up. Actually complete the square. Equals 29. Okay, right back to isolate the x, which we've just been doing. Yes.
How did you get 26?
Okay, good question. So let me do this for you. Okay. So I'm going to take 12 and I'm going to split it into 2 equal parts. Multiply them together. Okay, so this is what I did. I took 12 and I split it into 2 equal parts, which is -6. And then I squared it, and that's how I got the number. Does that make sense? Half it, square it. Because I half it because it has to be the same. I square it because I need the last term. Okay, isolate.
Why do you highlight the
Because I'm isolating the single x now. One of them is negative. One of them is positive. I notice these things are pretty much the exact same. Okay, so what was new today? That part, right? Where we set it up and we completed the square. Okay, so we went from a trinomial you can't factor into a perfect square trinomial with the leftover number over on the other side. That's what we did. We went from a trinomial you can't factor into a perfect square and the leftover number on the other side. All right, let's do it again. 3. Okay, so let's go with 3x squared plus 12x minus 18 equals 0. Well, I kind of see that everything divides by 3, so I am going to do that first. This is an equal, so I'm going to just divide everything by 3 because that works nicely. And before I continue, I'm going to check, can I multiply to -6 and add to 4? No. Okay. You have to complete the square. That is the only thing that's left to do. 2 lines. Set it up, complete it. No, that was just me grouping up the complete the square steps, which are kind of not really part of the solving. It's me getting ready to solve. So I'm sort of taking a side step to complete the square, and then I will go back to my solving. Yes.
So it would be 4.
Yes, it would be a 4. Okay, however you want to do it. You split this middle term into 2 even parts. Gets you a 4. Okay, and factor. Okay, all right, so I completed the square. Now you isolate. Yes.
Why do you randomly just add in the
Oh, because what do we do to complete the square? We pick the C number. We pick the number to make it a perfect square. Okay, now this problem didn't have the blank written in. It's because you didn't know you needed the blank until you decided that you wanted to complete the square. Okay? So I halved it and squared it. That's what I did. Okay. Isolate.
What does it come out? Why does square root come out to be like plus or minus?
Okay, because right here, when you separate the absolute value, the root gets the 1 negative and the 1, so the root gets a negative and a positive in front of it. Okay, so then I minus my 2, and I actually realize I have the same thing, so I can write it together.
You could also write it the other way around.
Oh, yeah, sure. If you want to write it plus or minus root 10 minus, it's fine. All right. Last, yes, Sasha. Yes, sure. All right, guys, here we go. This is it. X squared minus 3x plus 1. This is your last one. Okay. Multiply to 1. No. Right? I can't isolate. I can't factor. Means I have to complete the square. So I'm going to complete the square before I start solving again. Okay? All right, who can tell me what's the first thing I do to start setting up? Okay, go for it, Eve.
So you're going to loop go into both sides, so then come up x squared minus 3x, and then you want to leave a space for the new number on both sides.
Okay. New number on both sides. Love it. Okay, somebody different, please. What is my new number? Yeah? Okay, Rayan. What? Okay, that's part of the new. Yeah, okay. No, that's good. I like both of those numbers. So first he did 3 over 2. Then he's like, wait, no, I want 9 over 4. Yes, because you need the last term. Mm-hmm. Yes, thank you. Okay, so 9 over 4 was our number.
Wait, so wouldn't it be negative?
No, because negative times negative is positive. Okay, so then we're actually going to complete the square. Okay, maybe I do a little bit of scratch work over here. This is actually negative 4 over 4 plus 9 over 4, which is 5 over 4. Notice that the complete the square comes down to like the square equal a number every time. Yes?
Why did you do -4 over -4 plus 9?
Oh, okay, so I got you. Hold on.
The number is just that equal -1.
This is what I was doing right here. I was actually adding up those terms. So -1 is this. Because I needed common denominators to add them.
Okay,
Yeah. All right. Now that I've actually completed the square, I can now start solving. Yes, there are a lot of steps, but try to chunk your steps so that you're focusing on one thing at a time. Okay, so I do notice that I can simplify this radical at least a little bit because 4 is a perfect square. So I'm going to take the 2 out of the radical. And
Would
we
you
get,
leave it like that, or like 3 by 4, or would it mark this wrong?
say that again.
Like if you were to leave it like that on this map, would it mark this wrong? Like,
It depends upon what the directions say. If it says simplify, then you need to make sure to take out the perfect squares. And I think it does say simplify. But keep in mind, because we were adding a perfect square to both sides, that number should be a perfect square every time. Okay?
is it ever not going to be a perfect square? Like would you?
If you do some extra reducing by common factors, it might be. But if you notice that your denominator is a perfect square as you're working through the problem, I would leave it there and wait till after you square root. Okay, those things are like the same, so I'm going to just... Which, because those denominators are the same, I could write it like this. You don't have to, don't worry. You can leave it like that.